40. Predict the valence electron molecular orbital configurations for the following and state whether they will be stable or unstable ions. And then we have F2, 2+. All right. So before we address the mess down at the bottom, we first have to find out how many total valence electrons we're dealing with here. So the first thing we got to do is say, okay, we're dealing with fluorine, right? And fluorine on the periodic table is either in group 7A or 17, depending on what your periodic table goes by group number. But the lucky number here is 7s. 7s all around, because in general, fluorine has 7 valence electrons, but we have 2 of them. So 2 times the amount, double the valence electrons. So if I have 2 fluorines, I will multiply the 7 valence electrons by 2. And I'm just going to put valence electron as val E minus. E minus stands for electrons. So 2 times 7 is 14 valence electrons. But I wish it was that simple, because of course they got to give you a charge, right? They got to give us that +2. What does plus charges mean in chemistry? Well, pluses means that you lose electrons. And in here, you're losing 2 electrons from the total. So take that 14 minus 2, and now we have a total of, no, maybe I'll put total here. We have a total of 12 valence electrons. And this is going to come super important in a little while. All right, so we're just going to hold that off for a little bit here. Because now the next thing that we have to do is pick which general template am I going to use. Now I wrote down these 2 templates for you guys for your molecular orbital configurations. Just know the different templates is based off of sp orbital mixing. The information behind that is a little bit too advanced for Gen Chem. If you're taking this, in just a regular general chemistry course, this would come into like a majors chemistry course when you're dealing with like physical chemistry. So just for now, there's 2 different types. You just got to pick the type that we're going to work with. And that goes by the group number. We already said that fluorine was in group 7A or 17, and there's the 7A one. So in this case, we're going to use the bottom general formula. So what I'm going to do is I'm just going to take this and move it on up. As for the other one, in this case, we don't need to use it, so I'm just going to get rid of it. But if you need to, pause the video just to write it down, just to make sure that you know that you have the other one, just in case. But in this case, we're just dealing now with F2 and then 2+. Okay, so the question is now, well, here's the template. How do we make it F2's molecule, right? How do we make it its own? Well, the first thing is that I have these colored markers down here, right? The yellow highlighter and the blue highlighter, because we have to specifically say what s orbitals and what p orbitals are we working with. And these come from the periods. So I got to look back to where fluorine is. On the periodic table, fluorine is in period 2. And that number, even though I don't like that color mixing, that number, the 2, is going to be the number of your s and p orbitals. So 2's all around. So I have a sigma, that's this sign, a sigma bond, a 2s. I have another sigma 2s, but this is antibonding. Antibonding is always the higher energy state of your bonding orbital. So for every bonding orbital, you always got to have its antibonding equivalent. And then we have your sigma 2px. We got pi's, which is that, 2py, 2pz, 2py, 2pz, and then 2px. All right. Last thing that we have to do is actually put the total number of valence electrons into our configuration. And just know that since this was already written out for us, right, or I already, wrote it out for you guys, but just know that I wrote it in such a way that you're increasing in energy. So you're always going to start dropping your electrons in the lowest energy molecular orbitals and then gaining as you go from left to right. Now, every orbital that you have, you got a max of 2 electrons. So let's go for it. The first one is your sigma 2s. I need a total of 12 valence electrons, so I have none already that I said, so I'm going to drop the 2 in here. So I have 2 stated. Let's keep going until we reach 12. So here's the next orbital. I'm going to drop 2 electrons in here. So that's cool. I'm going to keep going because I'm not at 12 yet. Here's my next orbital, my sigma 2px. I'm going to drop 2 in there. 2, 4, 6. I'm not at 12 yet, so I keep going. Now here are 2 molecular orbitals that are grouped together because they have the same number of energy. So same energy place. So max of 2 electrons here and a max of 2 electrons here. So that's a total of 4 valence electrons. Let's see. Did we reach our max yet? 2, 4, 6. 6 plus 4 is 10. I got 2 more. And that one goes to the next one. So this is going to have to be a 2, which will make up the 12. 2, 4, 6. 6 plus 4 is 10, plus 2 is 12. And now, standard notation is you only write your electron configuration up until the last electron is dropped. So technically, since there are no electrons in your sigma 2px antibonding orbital, that goes bye-bye. You don't have to write it. But I just like to show it there just in case, for learning purposes. But on, a quiz or a test, if they're asking you for this, you just get rid of that part. So this is your valence electron molecular orbital configuration. Well, now where are we going? Well, they next want us to find out, is this a stable or is this an unstable ion? Now, when they're talking about stability, especially if they're talking about molecular orbital configurations, they're secretly asking you for a bond order. Because the bond order will actually tell you what bond is being made between those 2 fluorines. Would it be a single bond? Would it be a double bond, a triple bond, or maybe no bond at all? From that information, we can then state whether it's going to be stable or unstable. But let's first find out that bond order. The bond order formula is pretty simple. It's this one right here. So nothing really going on here. It's just a simple subtraction and a division. The hardest part here is to just know how many total bonding electrons minus the total number of antibonding electrons. And then once you have those, you subtract them and you divide by 2. So let's just set this up for now. My bond order would be equal to something minus something divided by 2. Now we just have to figure out these numbers. The antibonding is the easier one to do first. Now the antibonding, remember, you're always looking for that star in the upper right-hand corner. Well, here's a star. And here are stars. All the other ones, if we notice, they don't have any stars in the upper right-hand corner. That's bonding. But for these, you're going to tally up the total number of electrons that have the stars. So 2 electrons and 2 electrons. So 2 plus 2 is a total of 4. Going over here. Your bonding electrons are basically everything else. So it's going to be this 2, and this 4. So 2 plus 2 is 4. 4 plus 4 is 8. So we have 8 over here. All right. So now we just do the math. 8 minus 4 is 4 divided by 2. 4 divided by 2 is 2. Now, what does this actual number mean? Well, this represents what type of bond is going to be between those 2 fluorines. Think of this as the number of lines. So if you have a bond order of 2, that means that you're forming a bond that has 2 lines. And that is a double bond. So you're actually able to form a bond between these 2 fluorines in this case. Would that be a stable or an unstable ion? Yeah, this would be totally a stable ion. Just to put it into perspective, what an unstable ion would look like is when you do find the bond order, you would get a bond order of 0. And if a bond order equals to 0, that means that there was no bond made. And if there's no bond that's made, chances are it's pretty unstable. It's not going to bond. And that's the key here. So I hope this helped. What'd you think? Let me know in the comments. Subscribe to the channel. I hope you guys having a great day out there. Let's keep studying hard. And you wouldn't mind, we're almost at 30,000 subscribers, so please hit the subscribe button if you haven't already. Thank you so much for that. Thank you for, talking in the comments, helping each other out. It really is a great community that we're building, and my brother and I are so thankful for all of you that have reached out to us through the comments, through email. We're just really grateful that we can help you guys out in your classes. So just check the channel out, all right? I'll be talking to you soon. Bye-bye.